Hello and welcome to a video on 7-1, which is parallel lines and angle relationships. So we're going to talk patios by Madeline today. We've got two learning targets. We're going to make conjectures, which is a guess, about angles formed by a pair of parallel lines and a transversal, and then we're going to prove theorems about those angles. So let's take a look. So we've got this patio, and we have Matt working for a company called Patios by Madeline. A new customer has asked him to design a patio and a walkway. The rows of bricks in the patio will be parallel to the walkway as shown in the diagram. So far, Matt has used stakes to tie down two parallel strings that he can use to align rows of bricks. He also used paint to mark the underground gas lines in the house so that he can avoid accidents during construction, which is true. The string lines and the gas line intersect to form 8 angles. So here's the house, here's the patio, we got the walkway, but underneath we're going to look at the gas lines because we don't want an explosion in our neighborhood, right? So the gas line is crossing your two parallel lines at our stakes and it forms 8 angles. So I've got 1, 2, 3, 4, 5, 6, 7, and 8. So let's move on to the next page. So I'm going to use a protractor. Y'all are not going to use a protractor. You're going to trust me that I used a protractor to create these angle measurements. So trust me in that angle 1 is going to be 15 and angle 8 is going to be 65. So it's annoying. We got to flip back to our front page. But flip back, and so I'm going to say angle 1 is 115 degrees. Just trust me. And then we're going to say angle 8 down here is 65 degrees. Okay? That makes sense because angle 1 is an obtuse angle, bigger than 90. Over here, 8 is an acute angle, smaller than 90. So if I give you 2 angle measurements, you can actually find all of the rest. So what I want you to do is see if you can find the rest of these angle measurements based off those 2 angles. I gave you a hint. Try and think about vertical angles. Try and think about supplementary, linear pairs, 180. Okay. So press pause and try and figure out those measurements. So hopefully you got 115 on the left side and then 65 on the right side. So hopefully you saw some vertical angles going on. So for example, 1 and 3 are vertical. They have to be the same measurement. Same thing for down here, 8 and 65. We can those are also vertical. Now, to get the other measurements, you do need to think about supplementary. So for example, these 2 angles, 1 and 2, are a linear pair or supplementary, meaning they would add to 180. So you could say 115, take away from 180 to get that 65. Okay, so if you know one angle in a parallel line cut by a transversal, you know them all. So you're allowed to move things with vertical and then think about linear pair relationships, okay? All right, so that will be the case every single time, okay? The reason these numbers, like all my odd numbers were 115 and all my even numbers were 65, was based on how I numbered my parallel lines cut by transversal. And this will always be the case if you number them like this. 1, 2, 3, 4, 5, 6, 7, 8. Like if you snake them down, all the evens will always be one number, all the odds will always be the same number. Fun fact. All right. Let's get some vocab going on. That was loud. All right, so the gas line is the transversal of the string lines. So let's go back. The gas line is the transversal. So the transversal cuts the 2 parallel lines. Okay? Now, these angle pairs are going to have some certain definitions. So let's take a look at this math terms column. Transversal is a line that intersects 2 or more coplanar lines at 2 different points. And when 2 lines are intersected by a transversal, I get these following angle relationships. Corresponding angles are a pair of non-adjacent angles, so they are not touching, such that the angles are on the same side of the transversal, so like they're either on the left or the right side, and one angle is on the outside, so one on the outside, and one between, or on the inside, okay? So that is corresponding angles. So there are 4 pairs of corresponding angles. So for example, one corresponding angle, I'm going to go back to my picture, would be, let's see, let me erase this. So one example of a corresponding angle, let's start with 1. So 1 is on the left side of my transversal, so they've got to be on the same side, So I'm either looking at the numbers 1, 4, 5, or 8. And then one has to be on the inside of the parallel lines, which is all this junk right here, and one has to be on the outside. So that means 1 and 5 are going to be your corresponding angles. So they're the exact same, just shifted up. Okay? So one of them would be angle 1 and angle 5. Okay? There are 3 more pairs. I gave you one of them. All right? Let's move on. You're going to figure out the rest in a second. Same side interior angles are a pair of angles that are between the 2 lines, so your parallel lines, and they're on the same side. So this one gives it away in the vocab definition. Same side interior, they're on the same side, they're on the inside. Okay? This one only has 2 pairs, so let's go back up to our picture. I'm going to look on the right side this time. So 3 is on the right side, 6 is on the right side, they're on the same side, and they're on this inside of the parallel lines. So that's an example of same side interior angles. Angle 3 and angle 6. Okay, there's another pair. You're going to do it in a second. All right, the next one, alternate interior angles. So it's a pair of angles that are between the 2 lines because they're on the interior, and then they are on opposite sides of the transversal, hence the word alternate. So they're alternating, one on the left, one on the right. Interior, they're both on the inside. So let's take a look at this. For example, let me look at 5. 5's on the inside. Then I got to pick something alternating. So on the other side, but not touching, so it'd be 3 and 5. One on the inside, one on the outside. They're on the same side, but they're alternating. So angle 3 and angle 5 would be an example of alternate interior. Okay? So what I want you guys to do now is find the other remaining pairs. So give me 3 more answers for part A, give me 1 more answer for part B, and give me 1 more answer for part C. So press pause, and we'll go over those. All right, so the other 4 pairs of corresponding ones would be 2 and 6, 3 and 7, and 4 and 8. So I'll talk about that real quick. Corresponding is a tricky one because nothing is given away in the definition. So you've got 2 and you have 6. They're on the same side, one on the inside, one on the outside. 3 and 7. 3 and 7, same side, 3's on the inside, 7's on the outside. 4 and 8, again, 4's on the inside, 8's on the outside, they're on the same side. So corresponding is by far the trickiest one to keep straight in your brain. The next one, same side interior, we talked about 3 and 6, 4 and 5 was your other 2 angles. So both 4 and 5 are on the inside on the same side, 3 and 6 inside, same side. Alternate interior, we talked about 3 and 5, but you also have 4 and 6. So 4 and 6. One on the left, one on the right. They're both on the inside. So this is the inside of your parallel lines. Okay? All right. Those are some 3 very important vocab words that we'll be using. All right. So what we're going to do now, you've learned some vocab, and now we're going to make a conjecture about the types of angles. So based on the answers to items 1 and 2, I want you to make a conjecture, a guess, about what you think about each types of angles. So are they congruent? Are they supplementary? Okay, that's a hint for you. So try A, B, C, D. What do you notice? Are they congruent? Are they supplementary? I don't know. First, so corresponding angles are congruent. So hopefully you had that written down. So let's take a look at an example. I've got angle 1 and angle 5. I said they were corresponding. Angle 1, angle 5. One, they look the same. And then boom, over here, angle 1, angle 5. We know that they're the same. Okay? So how I remember it is corresponding, congruent. They both start with a C. Okay? Same side interiors. They're going to be supplementary. So same side sup. We got S's going on. Okay? So let's double check that. Same side sup. We got 3 and we have 6. They do not look the same. 3 is over here with being 115. 6 was over here being 65. So 115 and 65 gets you to that 180. So those would be supplementary. Okay. Last but not least, alternate interior angles. Those are going to be congruent. There's no really easy way to remember that, but they're congruent. So let's take a look at it. Alternate interior would be, let's say, 3 and 5. we'll go 4 and 6. Those are probably easier to see. They both look like very small angles. They're acute angles. 4 and 6, they're congruent. Okay, so the good news is in this lesson, if they look the same, they are the same. If you've got one small, one big, they're probably supplementary, and that's the nice part about geometry. Okay, so let's move on. Number 4. You're going to try number 4 because you get to do your own thing. It wants you to draw your favorite transversal. So you could draw this transversal, this transversal, this transversal, doesn't matter. And then it wants you to number the angles. So like how we did, number them 1, 2, 3, 4, 5, 6, 7, and 8. And then record the measure of each angle. So make up an acute angle measurement, make up an obtuse angle measurement. I'm going to stick to some nice even numbers like 10s, 20s, 30s. But try 1, 2, try 4 in A and B, and then we'll go over answers, and I'll show you another example. Press pause. Here's my example. You guys probably did not have my example. Go you if we think the same. I drew my transversal going the same direction as the one before, I think. I don't remember. But I picked an angle measurement 20, so I've got 20 here. 20 is the vertical angle. Corresponding are 20 and 20, so those have to be the same. My obtuse angle was 160 because 20 and 160 make 180, and then just all the big angles are 160. Okay? Awesome. So, again, once you know one angle, you know them all. So, does your answer in item number 4 confirm the conjectures we made in item number 3? So, let's talk about that. So, in item number 3, we said corresponding angles were congruent. Let's double check to see if that's true. 20 and 20, those are corresponding, they're congruent. We also said alternate interior was congruent. So as 20 and 20, they're alternating on the inside, they are congruent. We said same side interior were supplementary. 160 and 20, they add up to 180, they're supplementary. So all the stuff we did in the previous problem worked for my example. Okay, so yes, it was all true. Okay, so evidence that confirms a conjecture provides support for the conjecture. So I guessed that these certain angles were congruent and these certain angles are supplementary. We did a new problem, everything worked out, and so you guys did a problem at home or wherever, someone else did a problem, someone else did a problem. So everyone did a problem differently, but we got the same information. So we pretty much proved it to be true. Whoops. All right, so moving on to 6. The corresponding angles postulate involves angles formed by 2 parallel lines cut by a transversal. So, based on our early conjecture, our guess, we said that corresponding angles were going to be congruent. So we're going to write an if-then form statement. So I'm going to give you a hint. So if 2 parallel lines are cut by a transversal, so that's my if, then I know corresponding angles are congruent. And that is the rule. That's going to be our postulate. Okay, we're going to assume it to be true because we just did a ton of examples and they all worked out. So the corresponding angles postulate is if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. If you need to press pause to write that down, go for it. Do you need to prove that a postulate is true before you can use it in a proof? No. So in geometry, postulates are accepted to be true without proof. So I don't need to do a formal proof of corresponding angles postulate based on the conjecture we made in the past. Okay, so postulates you don't have to prove. We accept postulates to be true. So the segment addition postulate and the angle addition postulate, we never proved those. We just knew that part plus part was whole. Okay. All right, so y'all are going to try number 7. Very similar to what we just did. I want you to write an if-then statement based on alternate interior angles and then based on same side interior angles. So, a hint, you're going to literally copy and paste if 2 parallel lines are cut by a transversal, then, and then change your vocab words around. Okay? All right, try 7, A and B, press pause, and I'll give you the answer. Pause myself. Answers! So, if you have 2 parallel lines cut by a transversal, then alternate interior angles are congruent. So that is the alternate interior angles theorem. Do not ask me why it switched to theorem and not postulate. I do not know. All right, last one. If two parallel lines are cut by transversal, then same side interior angles are supplementary. Okay, so things are either congruent or supplementary. Same side interior angles is the only one that's supplementary. All right. My computer's frozen. There we go. So this is not in your notes, but I wanted to show you a visual representation of what this looks like. So for example, I have two parallel lines cut by a transversal. So if you see this arrow symbol on a line, that tells you it is parallel. So I have two parallel lines cut by the transversal. So if that is true, then I know my corresponding angles are congruent. So I'm allowed to say this angle is congruent to this angle. You're also to say all the other four ones. This angle is congruent to this angle. Okay? So that allows you to make some marks. Let's look at another example. If two parallel lines cut by a transversal, so again, same picture, then I know alternate interior angles are congruent. So I'm allowed to make these congruent marks alternating on the inside. Same thing over here. I'll do a blue one and a blue one. Okay? Now we can't make the marks for supplementary because these marks mean congruent, but here's a visual example. Okay? All right. Thank you for watching part 1, which is the notes section. Part 2 is going to be where you're going to practice and do some algebra, do some proofs, okay? So thanks for watching this part. Once you're ready to practice and learn the next part, watch part 2. Peace.